Hey, so you had a question basically asking how this bromine here is converted into a carboxyl group. So let's go over that. So looking at your question, the first step was protecting this ketone with a diol. So as we add this diol, this ketone is going to be protected and converted to this structure here. Now the next step is reacting our compound with magnesium. So if you might remember, so firstly, let's keep in mind that our compound has bromine on it. If you might remember from OChem 1, whenever you react an alkyl halide, so any compound with bromine on it, with magnesium, this is how you synthesize a Grignard reagent. So let's go over quickly what Grignard reagents do. So firstly, you'll react your alkyl halide with magnesium. What that'll do is insert magnesium into the bond between carbon and bromine. I want you to keep in mind that magnesium is a metal and carbon is a nonmetal. Bonds between metals and nonmetals are ionic bonds. So ionic bonds, when you put them into solution, they're actually going to dissociate, leaving your magnesium with a positive charge and your carbon with a negative charge. This negatively charged carbon is a good nucleophile, and that's because nucleophiles like to have negative charges. They like to have lone pairs that are readily available to go out and attack other atoms, attack electrophiles. So electrophiles like to have partial positive charges because a negatively charged nucleophile is attacking them. Opposites attract, so positive is attracted to negative. Electrophiles like to have partial positive charges. So the place where our nucleophile is going to attack here is going to be our carbonyl carbon. It has a partial positive charge because it has this electronegative oxygen pulling up on it. Electronegative atoms like to hold onto electrons, so they'll be partially negative, leaving this carbon with a partial positive charge. So this partial positive carbonyl carbon will be our electrophile. The nucleophile will attack the electrophile, pushing the pi electrons between carbon and oxygen up. That negatively charged oxygen will later pick up a hydrogen from solution, turning it into an alcohol. And you can see that in Grignards, we just added our carbon compound from our Grignard reagent to our carbonyl, which I've highlighted in yellow. And here our carbonyl just turned into an alcohol. So let's look at how that relates to your question. So we're reacting your compound with magnesium. That's going to form our Grignard reagent, which dissociates into solution, giving this carbon a negative charge, making it a good nucleophile. The next step is reacting your compound with CO2, which CO2 here is actually going to serve as your electrophile. Just like here, your partial positive carbon served as your electrophile. This may look weird, but it's really no different because this carbon has two electronegative oxygens pulling away from it. So these oxygens are going to have a partial negative charge, and this carbon is going to have a partial positive charge, making it a good electrophile. So this negatively charged oxygen will attack our partial positive carbon. That's going to end up displacing our pi electrons, pushing the pi electrons between carbon and one oxygen up onto oxygen. So now we've ended up attaching our CO2 here to our molecule here. So now the next step of this reaction is adding H+. It turns out when you add H+, just like here, when you added H+, this oxygen turned into an alcohol. Here, your O- is going to pick up that H+, turning it into an alcohol. This is how we formed our carboxyl group. And whenever you add H+, you can't forget that this will hydrolyze protecting groups and remove them, and your product will be your carbonyl. So whenever you add H+ to protected carbonyls, you'll get back to your carbonyl. So just going over the reaction once more, we start out by protecting our carbonyl, and then we add magnesium, and then that is going to form our Grignard reagent. Whenever we react this with CO2, our negatively charged carbon from our Grignard reagent will attack this carbon from CO2, pushing the electrons between carbon and oxygen up onto oxygen. This negatively charged oxygen in our next step is going to grab H plus from solution, turning this section of the molecule into carboxylic acid, and then H plus will remove our protecting group and give us back our ketone.